Hi everyone, so today we'll continue with graphs, and last time we talked about depth first search on graphs, and today we'll talk about another kind of search, that is breadth first search. So before we talk about this algorithm, we have to know another type of representation of graphs. So we have talked about adjacency matrix before, so today we are using another way to represent our graph, so that is adjacency list. So an adjacency list is a data structure used to represent a graph where each node in the graph stores a list of its neighboring vertices. And here's how we will build an adjacency list. So first we'll create an array of linked lists of size n, where n is the number of vertices in the graph. Then we'll create a linked list of adjacency vertices for each vertex in the graph. For each edge u, v in the graph, we'll add v to the linked list of u, add u to the linked list of v if the graph is undirected, and otherwise we'll just add v to the list of u if it is directed from u to v. So here, for the code part, we'll talk about that later, and we'll first look at our breadth first search, or BFS, for a graph. So BFS is a fundamental graph traversal algorithm. It involves visiting all the connected nodes of a graph in a level-by-level manner. So we'll look into the concept of BFS here. So here's how it works. And first, we'll include the starting node into a queue and mark it as visited. So we'll still use the visited array to check whether a node is visited or not. But what is different from DFS is we'll use queue to store the nodes, while in DFS we use the stacks. And here, while the queue is not empty, we'll just dequeue a node from the queue and visit it. For each unvisited neighbor of the dequeued node, we'll include the neighbor into the queue, mark the neighbor as visited, and we'll terminate, do the termination step. That is, we'll repeat step 2 until the queue is empty. So this algorithm ensures that all nodes in the graph are visited in a breadth first manner, starting from the starting code. So we'll use a simple graph to illustrate the difference between BFS and DFS. So for example, we have a very simple graph here. When we do DFS, we start from a node and check this and go back and check this. So we go all the way down until there's no way to visit another node. However, in breadth first search, we'll visit nodes level by level. So here, then we'll visit this node, and on the same level here, and at last this node. So this is the difference. And we'll talk about how it looks like in this graph as an example. So first we have a queue and an array visited. Then we first visit the node 0. So it is in queue and it is in the array visited. Then 1, 2, and 3 are that will be marked as visited because 2 and 3 will be inside the queue. And at last 3 and 4 be inside the queue, and all of them will be visited. And here we are check the code to do the BFS algorithm. And first we have a class graph, so where we store the graph. And here we are talking about how we use the adjacency list to represent the graph. So we can see that we have an linked list here, and we are just write a method called add edge, and it has two parentheses u and v. So these are the vertices that uv will be the vertices that we want to store, and we are just add v to the linked list of u if there is an edge starting from u and ending from v. And this is our method to do the breadth first search process. So first we'll define a queue and an array Boolean type, that is Boolean type, to store the vertices that are already visited. And when we start from a node, that is start node, usually 0, and we'll just first mark this as true, and we'll add this node into the queue. Then we'll have a while loop here. So if the queue is not empty, we'll just repeat this process, that is this step 2 here. So inside the while loop, we'll first dequeue a vertex from the queue and print it. So how we dequeue it is just to pull it from this queue. So when you call this method, you will receive the value, the element at the top of the queue, and it will just be removed. So here we will choose to print it out, and here we define a for loop to traverse the adjacency list of the current node we just get from this queue. So if this node has a neighbor that is linked to it that is not visited by us, we'll just visit this neighbor. So how we visit it is we first mark it as true, because we have nowhere else to mark it as true except from the start node. So we have to first mark it here. Then we'll just add it into the queue. So this is what our main method looks like when we traverse a graph using breadth first search. So here is how you define the graph. And for example, if you have 5 vertices, you will add the edges 0, 1, 0, 2, 1, 3, 1, 4, 2, 4, for example. Then you will just call the method to print the elements in the order of the breadth first traversal that we have talked about. And that is all for today's activity. Thank you.